Welcome learners. So today in this session we will study about the R visualization of data. Now what we have seen in the previous session is that we have seen different types of files for data analysis. So we have seen the data in Excel form, we have seen the data in CSV format, in JSON format. So before proceeding to the visualization part, you have to input these files and then you have to visualize the data. So data visualization is very important aspect of understanding what is happening inside the data. So it is very important that when you are inputting the data, you always visualize the data in such a way that you can get familiar with the data and you can discard out any unnecessary part that resides inside the data. So that is why the visualization of data is very handy, is very necessary, and most of the researchers before processing the data, they always visualize the data first. So the types of data visualization, there are different types of data visualization techniques that exist in R. So all the techniques like all the charts like pie chart, the bar chart, the line chart, they are already there and they are very easy to access and they are very easy to understand and they are very easy to implement in R. So you just have to just have to write 2 or 3 lines of code to get your desired output. Now the R programming language has many helpful chart and graphic library packages. So again, it's an open source language. That is why the packages that are already being existence in R, so you just have to, some of them require packages, some of them are already built in R, so there is no need to install extra packages for that. So the first thing I want to, the first particular data visualization technique is the most common one, that is a pie chart. So each slice has a name and chart has also the chart shows the related numbers. If you have seen a pie chart, you already know that like there will be a pie and each slice has a particular quantity or a particular name attached to it, and it also shows you the related numbers. So it's very easy to implement pie chart in R. You just have to use the function name pie and again the function quotes, that is your round brackets followed by it. In the round brackets you just have to give the parameters and your pie chart is already being, and you can display the pie chart on the plot part of your R studio, or you can easily save the pie chart file as well. So again, the pie chart function is in R is used to make a pie chart and it accepts a vector of positive numbers as input. Labels, colors, titles and more can all be adjusted with the help of extra parameter. I'll show you that there are, you can change the labels, you can change the colors, you can also change the titles that can be, that is being available in the parameter part of the pie function. So the example of a pie chart, so before proceeding with the example of a pie chart, so the syntax is very simple, as you can see. So pie followed by X, then labels, radius, then main, then column, that is col, C-O-L, col, and then clockwise. So each of these are the parameters that are attached with the pie function. So X can be a vector, which means that whichever file you want to like you can input the CSV files and make a pie chart of it, but you can also give X a vector number or numeric values, anything you want on the go as well. So I'll show you in this example that we can assign the values on the variables as well, or you can input the values from the CSV file or JSON files as well. So again, X is nothing, just it's a vector which contains the numeric value for which we will build the pie chart, and then there will be labels that if you want to give description to each slice of pie, you can present labels there, and then there is a radius. So what radius you want, the value can be between -1 to +1, and then there is a main that indicates the title of the chart, and then there are columns. So COL is color, sorry, in the previous one I told you that COL is column, but it's color, so it indicates the color palette. So you can decide accordingly which color you want to use, and in the color palette, which particular color palette you want to use in a pie chart. The last one is clockwise, so it's a logical value indicating if the slice are drawn clockwise or anti-clockwise. So it is dependent upon you, so it can either be true or false because it's a logical value. So this is a simple example of a pie chart. Suppose you have taken a variable x and you have inputted 4 values there. So they are not percentages, simple values, and they are assigned labels like 34 apples, 43 oranges, 10 kiwis, 53 bananas. So it is like that, and what you are doing actually, you are simply naming the file as PNG. So if you want to save the chart file that you will generate in the PNG format, you can simply write PNG in file and then whatever you want. So the name of the file, like if you want to generate a photo or a PNG format image, you can simply write the name of the image, so it will be generated, and then you start plotting the chart. When you write pi x labels, so it will directly plot the chart in the plot area of RStudio. Or if you are not able to if it is not visible there, what you can do is that you can simply write dev.off, dev.off. What happens with that is that your file will be saved inside the current working directory. So if you're not able to, sometimes there will be an error that you will not be able to see the chart in your plot area. So some settings are there, you can adjust it. But if you want to see the generated chart, you can simply write dev.off. So what will happen here, fruits.png file will be saved inside your current working directory, so that you can go there in the current working directory and you can view the chart. So again, titles and colors, you can also change the titles and colors of a pie chart. So simply you can because there are more parameters that is already being discussed in the starting, that there are many parameters that are present in the pie chart, so you can adjust those parameters accordingly. So if you want to change the title and the color palette of there, so just have to access those argument. So the number of values in our chart should corresponding in length to the length of the palette, therefore we rely on length of x. So I'll show you. So if you want to change the color palette, or if you want to change if you want to give the title, like if you see here, the title in this particular slide is fruits pie chart. So what you have to do, everything is similar. We just have taken the pi function and we just have added some arguments there. If you check here, x labels are as it is. Now main, so main is the title of the chart. So what is the title of the chart? Fruits.pie.charts. And what is the color? So color, you can select the color palette. So what we have taken is that it is dependent upon the what is the length of x. So length has the x has 4 particular values that is being there. So what can you do is that you are just writing color palette as rainbow 4. So length of x is 4, so it will be rainbow 4. So it will assign 4 different colors to different particular values. Okay, so kiwi is assigned different colors than the previous one. If you can check in the previous one, the color palette was normal, but if you want to change the color palette with the rainbow color, so there will be bright colors here like green, red and purple, something like this. Again, if you are not able to view the file in the plot area of your RStudio, you simply just write dev.off. And again, what will happen there is that it will display a output that PNG file is saved, and then you can go into the current working directory and then you can view the file. Similarly, another example is that you can also with the help, you can also add legends. Legends means that if you want to give more information regarding the pie chart, so you can add it with the help of a legend. So if you see this particular figure here, so there are some square colors that are being added, and it is displaying that which particular color indicates which particular fruit. So if you see at the top right hand side, you will see that apples are given a red color, and then green colors are given to oranges, and you can view that different colors are being assigned. So this is to add more information to the already present pie chart. You just have to add one more particular line, that is legend. So if you see the function legend there, after you have drawn the pie chart, you just have to add one more function, that is legend, and you can write where you want to add the legend. Like in this particular case, we have added the legend to the top right, which is the most used case. So at the top right, and to which particular fruits that legend will be added to, it is also displayed like apples, oranges, kiwis and bananas. And then there is CEX and fill. So fill is again rainbow color fill, color palette is fill, and you can simply write this particular piece of code to add the legend to it. So again, if you are not able to view the file, you can simply save the file and you can double click it, and you can view the file as well by writing dev.off, dev.off. Now another example is that you can also draw 3D pie charts, but they are not inherently present in the R language. So you just have to install the library, that is plot tricks. So first you install the library by going in towards the tools, and then you are clicking on the install packages, and then you are writing their plot tricks, and you will install the required packages. When it is installed, you just have to go towards the R console or your R script, and you just have to write library.plottricks. So it is just to import the library that you have installed. So now what you have to do, everything is very similar, the code is very similar. You just have to write X, which is a vector, and then the labels are very similar, like apple, oranges, kiwis and bananas. The example is very same. So PNG file, you are just naming the file, and then only thing that will change is plot 3D, pie 3D. So in the previous one we used to write only pie. Here we can write pie 3D followed by X, followed by labels, followed by something called explode.1, and then main file. What main means, that what you want to give the title of the chart. So this is pie chart of fruits, it is the title given, so you can view it in the figure, that is the same. So again, dev.off is to save the file. So similarly, another piece of visualization is bar chart. So you can also use bar chart to display certain aspects of data. So again, it is very simple to implement bar charts in R programming. So when displaying a numerical data, so bar chart uses rectangular bars whose length are proportional to the values of underlying variables. So that is why the bar charts are very useful to quickly view the data, that whichever particular part is more, whichever particular part is less, dependent upon the data. So again, to use the bar chart, it's very easy to only use the name bar plot. You just have to use the function name bar plot, round brackets. Whenever you use the name bar plot, and what you do, in the bar plot there will be round brackets attached to it, and it's again a function, because the round brackets indicate that it's a function. Again, some parameters that will be attached to this bar chart, and you can accordingly change the parameters according to your needs. So different bars in a bar chart can be represented by different shades of color. This can also happen. So again, the syntax of bar plot is very easy. So it is hxlab ylab main followed by names.arg, and then col, again it's the color that you can give to the graph. So H is again a vector or a matrix, yet you can like these are the values for which you want to draw the bar chart. And X lab is the label, X axis label, Y lab is the Y axis label, and then there is a main. So main is again the title of the chart, and names.arg is a vectors of names appearing under each bar. So I'll show you what do I mean by this. So this is how you draw a simple bar chart. So you just take a variable h, and in that variable you are just inputting some values, and you are again naming the file name of this particular bar chart figure. So you are naming it, so the name is barchart.png. So you can save this particular file in the png format, and then you simply write bar plot. So you see here we have not given any kind of a labels here, so we can give it, but here in this it is only a one dimensional data. So you can easily see that the third value is the less value or the least value of 10, and it is easily visible from the bar plot. So that is why bar plot can quickly visualize that which particular part of data that you are dealing. So again, if you want to save the file, you simply write dev.off. Okay, so this is a very simple bar plot. So again, if you play with the arguments of bar plot function, so you can again generate very beautiful charts here. So see, in this case, if you want to change the chart labels, if you want to give the labels to the chart, and another, like you can give the title and colors also. So if you see here 34, 43, 10 and 53 and 65, so the names corresponding to these values are there. And again, this is a marks that is being assigned to a particular name, that is the name of the student. And if you see here, previously we have only used one variable bar plot h, and you do not have to do anything, so it just directly draw a plot, but it is only one dimensional set. So there is no, what you say, at the y axis there is no names or any kind of a labels that are given. So in order to add it, you just simply write h comma names. Names means that these are the labels that will be every bar will generate, or every bar will denote a particular name. So name here is John, Tom, Harry, June and Tim. So another one is arg is assigned as m, and x lab means the label of x axis is students and the label of y axis is marks. So you can see it from there. And then the color that is being the color is set as blue, so you can see the chart is blue. And main, you can give the name title of the chart as marks chart. And what will happen here is that the border, if you can clearly see, the border of every bar is red, so you can also give the border to it. Okay, so again, if you want to save this particular file, you simply write dev.off, so it will save the file into your current working directory. Similarly, if you want to draw a group bar chart or a stacked bar chart, you can again use very simple piece of code. Okay, so that is shown in front of you. So here you can see, here is that there are three particular sets that are given. First is colors, months and something called regions. So east, west, north, and colors, months are given as March, April, and colors are given as green, orange and brown. So what is happening here is that you have create the matrix of the values. So these are the some values, like you can consider these are vectors, and the number of rows and number of columns. So this is a matrix who have 3 rows and 5 columns, and it is entered by row. So it is row by row entering. So it is 3 by 5 matrix. So it has total 15 elements. 3 by 5 is 15. And again, simply name the bar. So name the file, whichever you want to generate. You simply name the file and you simply write bar plot. Then you can add here values, that is the matrix that you have that we have declared over there, and then you can give that the title of the chart as total revenue, and then you can add your dimensions that we have given. So you can add names here, and then you can add arguments as months, and again the label x-axis label can be month, y-axis label can be revenue, and color palette, that whichever color palette you want to use. Now again, if you want to display more information, the legend function can also be used. So these are some of the legend function can be set as top left so that it will be clearly visible in the chart. So again, if you want to save the file, you simply use div.off. Okay, moving on forward with another visualization technique that is very popular is box plot. So this particular technique was basically used by the researchers to simply put out the error values that you have drawn a particular model, and that model has some values that are original values. Okay, so what it means is that suppose you have built a ANN model, and that ANN model will be trained on some data, and that some data will have there will be a testing data also, but that some data we already have the original values, and then we will have the testing values. Okay, so testing values will be the original values, and we can predict the values for which we are testing our model. So again, there will be two values. First is the testing values. Testing values will be the original values, and there will be predicted values. So the difference between them is the error of the model. What do I mean by this is that there are original values that is originally present inside the data, so which particular column you are predicting, and then there are values that are predicted by the built model that you have given the training data. So the difference between these two is your error. So you can simply use these bar plots to display the error, that whichever, if there are 4 or 5 models, you can simply draw a bar plot to indicate that which particular model has the least amount of error. So box plots are very useful in that particular visualization, that which particular model is more efficient as compared to the other one. So it is used to evaluate the evenness of a data set distribution. It does this by segmenting the data into middle and upper quartiles. The chart shows the range of values found in data set as well as its median, first quartile and third quartile. So I'll show you what do I mean by this. Box plots can also be drawn for multiple data set to compare their respective distribution. So mostly box plot will be used to check the evenness of the data, and it will show you the respective distribution of different data sets also. So again, the syntax is very simple. It's very close to the previous syntaxes of the charts we have seen. So box plot followed by x will be a vector or a formula where you can simply, this is x is actually the values for which you want to draw the box plot, followed by data, followed by notch, var width, names and main. So names, main we have already seen. Main is the title that you want to give to the box plot, and data is your data frame. X is a vector or a formula. Notch is a logical value, so it can be true or false. If you set it true, there will be a notch drawn at the both ends of the box. I'll show you in the example. And again, var width again is a logical value, so it is set as true to draw the width of the box proportional to the sample size. So it is again, you can set it as true or false. It is dependent upon how you visualize, how you want to visualize your data. And names are the group labels which will be printed under each box plot. So I'll show you. Okay, so suppose this is the data that we are taking. So this is miles per gallon and number of cylinders, and these are different models of the car. So this particular empty cars data set is already present in R. So these are inbuilt data sets. So you can simply use by taking input empty cars and then by taking the combine function, and you can simply write mpg and COIL. So it will only take those columns mpg and COIL, because empty cars have 6 or 7 columns, so it can take only 2 columns if you want to do that. And you can print the head means you can simply print the initial values like 4 or 5 values, that what actually this data set contains. Now if you simply want to draw a box plot of this, what you have to write is start with PNG file, whatever you want to name the PNG file, and then start with the box plot, and then you use mpg is miles per gallon, and then there is a relation symbol. So it's showing a relation between cylinder and LPG. So mpg, then this is a relation symbol with SCYL, and whatever data you want to input here. So data input that we want is the empty cars data set, which is already being present there. So you can directly write empty car, so it will understand, and then you can give the x label and y labels, x axis labels and y axis label. So cylinders are the number of cylinders and mpg is the miles per gallon, and then you can give the chart a name like mileage. So this particular chart shows you the mileage of a particular car. Now you can again save the files by using dev.off. So if you see here, the y-axis represent the cylinders, and another axis represent miles per gallon, and it also indicates that some cars take more cylinders. So this particular chart can show you the relation between miles per gallon towards the cylinder. So that is why we are using that symbol mpg, box plot, and then mpg, and then this hyphen followed by a cyl. So this is used to show that if there is a relation between the miles per gallon to the cylinder. So it can easily be visible from this box plot. Now moving on forward, you can also draw the box plot with notch. So if you can see here, you just have to set the notch value as true. Now another thing is, you're drawing the same relation mpg miles per gallon with respect to the cylinder, and then data is same, the x lab and y lab main is your title, then match is true, var width true, and then you can also assign colors to a particular bar plot. So it is C followed by red, green, blue. So if there are 4 boxes there, so you can set the color accordingly. Similarly, you can also assign labels to the towards the end there. So like high, medium, low, as you can see from the figure, you can also assign the labels at the end of it. So by using simply names, and then you can again save this file as by writing dev.off. So the next visualization technique is histogram. So histograms are again they are basically used for distribution, to show that there is the values that are being distributed across a discrete interval. So discrete means that they are like there is no in between point values. So everything is at certain interval, like after 10, after 20, after 30. So the values for a given variable are displayed graphically as a histogram, which shows the distribution of these values across discrete intervals. So it's like a bar plot. So histogram is like a bar plot, but only it organizes the values into continuous bands instead of the discrete ones. So I'll show you the example of a histogram here. So you can see here. So this is again a histogram that shows you the weight, and which contains weight and frequency. Like it shows you that if you assign a value to a particular, if you assign a value of a weight, it will show you that frequently how much people have how much weight. Okay, I'll get back to it. So again the syntax is very simple. In this you just have to write the function name hist, HIST, followed by v is again a vector, then main x lab followed by x limit, y limit, and then there is brakes, color and border followed by it. So now check here, what is x lab? You already know that this is the label of x axis. X limit is used to specify the range of the values of x axis. So you can also specify the range of x axis, and again y axis limit you can also assign by using the y limit function. Now brakes is used to mention the width of each bar. So I'll show you. So see this example. It's very easy to draw a histogram. You just simply have to uh, use the format of the syntax of the histogram. So again, take the v as vector, so you can assign different values to it. Again, you can save the file by using png format. Then you can create a histogram by just writing hist v already given to it. Then you can give the labels to the x-axis and y-axis, and then you can set the border to any color. So if you want to save it, you can simply save it with the help of div.off. Again, you can change the range of x and y values. So how? So simply, again, if you see here, everything is similar. Only thing that will be changed here in the hist function is that we are using the argument xlim that is being set from 0 to 35. So if you see here, the xlim is set from 0 to 35. So check the weight part is ranging from 0 to 35, and the y lim is set from 0 to 8. Again, you check the y part here, that is being given from 0 to 8. Now again, you can save the file with the help of a div.off. Now line plots are also there. So line plots are very simple plots. The example of a line plot is a graph in which lines are drawn between a set of data points. It's very simple. So you just have to take certain values, and you can simply use the function plot to draw a line graph. It is one of the simplest graph in R to draw. So you can also draw multiple line plots. I'll show you one by one. So the syntax is very simple: plot followed by v, this is vector. Type is takes the value p value to draw only the points. Okay, so I to draw only the lines, and o to draw both the lines and plots, or lines, points and lines. Okay, so if you change the type to o, it will draw both the points and lines. So if you only use the type to p, so it will only draw points here. Similarly, it is again xlab and ylab is the label for x-axis and y-axis, followed by the title, that is, you can also set the title as main. So, and color, you can set the color as whatever color palette you want. Now if you see here, this is a simple line chart. What we have taken a vector of values, and simply start with plotting. So plotting vector, type is O. Now it can use type O means it will use points as well as lines. So if you check here, so towards there are two, one when it is increasing, the line plot is going in the increasing direction, there is 3 points in that. So because of the type O, you can show the points, and if you want to change the type, you simply write point here p, so it will only show you points. Similarly, if you want to change the line chart title, color and labels, you can simply play with the arguments here. So in this particular part, you can also give maintenance cost chart. If you see, this is a maintenance cost chart. You can give the title with the help of a main label, and then you can also give the x-axis name and y-axis name. So the maintenance is shown in thousands. So this is 10,000, 20,000, and these are the months. Like for first month it takes 8,000 maintenance, second month it takes like 22,000 maintenance, something like that. So this is a maintenance cost chart. So if you want to draw multiple lines in a line chart, it is also very easy. You simply have to repeat you have to write two particular sets. Okay, so if you see here, there are two vectors in this particular example, v and t. Everything is same, but you have to write only two input as vectors, and then you just write plot followed by a vector. Then type is O, again points and line. Then the color is set to blue. You can change the color to anything you want, and then you can set the v lab to month, and then y lab to maintenance cost, that is in 1000, and you can give it to the color, whatever color you want. And again, you have to add one more function that is referred to as lines. So that function will denote the next vector, that is your t vector. So you take the lines function, and then you denote write t there, so that it can understand that there are multiple lines in a line chart. So this is how you can draw multiple lines in a line chart. So another visualization technique is your scatter plot. So again, multiple points are plotted on a Cartesian plane to form a scatter plot. So the horizontal axis will represent one variable and the vertical axis will represent another. So scatter plot is again used with the same function, that is the plot function. So I can show you. So use the plot function and then x, y main, x lab, y lab, x lim, y lim. So these are the limits, and then there are x's. So most of the functions you have already, most of the arguments you have already seen, only new argument came here is x's. So it indicates the axis part indicates whether both axes should be drawn on the plot or not. Okay, so I'll show you what do I mean by this. So again, this is the data set that we are taking. So this is weight with respect to the miles per gallon part. So weight of the vehicle and then the miles per gallon. So we have taken two values, weights and miles per gallon, and then we can give the name to it, and then again draw the plot here. So we are taking input dollar, means that if you want to select a particular column, that is weight, and at the y-axis we are taking input mpg and all the other usual arguments. When you set it, the scatter plot will appear like this. Whatever values that are there in weight and mpg, it will be displayed on the scatter plot. Okay, so with this, your data visualization techniques, all that are being used in R, how to build these particular charts in R with code we have seen. So in the next session, we will try to see the data analysis using R with different techniques like linear regression and multiple linear regressions there, and we also see what are the advantages of using data analysis in the next session. So thank you for listening, and you can move